All right, guys. So this is a really hard problem. I had to look at the solution to this problem actually, and I didn't even understand the solution first, which is why I am showing you how to do it today, right? To get you to really understand the solution, right? It took me about like 30 minutes to really understand what was going on, all right? So let me show you how to do this question right here. It says, which of the following describes the set of values of A, all right? A is a variable of A for which the curves x squared, let me write this down, x squared plus y squared. Let me write this really small at the top because I'm about to draw something. X squared plus y squared is equal to a squared, alright? Which describes the set values of a, alright? Here's a. And y is equal to x squared minus a. And the real xy plane intersect at exactly 3 points, right? So it's like from the top, it says, which of the following describes a set of values of a for which the curves x squared plus y squared equals a squared and y equals x squared minus a, and the real xy plane intersect at exactly 3 points, right? So it's asking us, what is the interval at which um, these two lines, or these two graphs intersect each other, right? The interval. So let's draw ourselves a graph. And this is the easy part, alright? This is the easy part. And now the hard part is finding a way to graph these two, alright? So let's take a look at y is equal to x squared minus a, alright? That one's an easy one to graph, right? So we're just going to graph it with, we know that this is a parabola, but we're going to shift it down, a units down, alright? So we're going to put a graph, let's put it in this green color. So we have this little graph right here, right? And it intersects this y-intercept at point 0, negative a. Alright, so 0, negative a, okay? So that's the easy part, alright? Now how do we graph this one right here? X squared plus y squared equals a squared. And so, you might do what I did before. As what I did, I did the algebra, I subtracted x squared on both sides. But really, all this is right here is a circle, right? Remember what our circle is, alright? Our circle is x minus h squared plus y minus k squared is equal to r squared, which is the radius, alright? And that's all this is. This is x minus 0 squared plus y minus 0 squared is equal to a squared, which is the r right here, right? So let's draw a circle, alright? Let's draw in this yellow color. We're going to draw a circle. So we have this very ugly looking circle right here, but it'll do, alright? And we know that this right here, it'll intersect at 0, negative a as well in this circle, because we know that a is going to be the radius, right? A is going to be the radius of this large circle. And also 0, 0, since we have x minus 0, y minus 0, 0, 0 is going to be the center. And if we were to extend a line out here, that would be the radius. A would be the radius, alright? So, now how do we figure out the rest? All right, we drew the graphs in. We know for a fact that the lines intersect each other 3 times, but we're just trying to find the intervals. All right. So what set of values for a would allow us to have a graph like this? All right. So let's do the algebra now, the real algebra. All right. So we have this y equals x squared minus a, alright? We have this y value set for us. So let's do x squared minus a squared, alright? Because we're just going to plug this y value into here, alright? So x squared minus a, I'm going to do that. I've already done that on my piece of paper. That is, I believe, here, let me draw it down here. That is x to the 4th minus 2ax squared plus a squared plus x squared right here is equal to a squared. Alright, and these two a squares can cancel out each other. So that means we have x to the fourth plus x squared minus 2ax squared is equal to 0. And we can factor out an x squared from this side of the equation right here, right? So take out x squared, so we'll have x squared plus 1, actually, yeah, minus 2a. Is that right? I believe so. Is equal to 0. Alright? Or yeah, we have x squared. And then we have x squared. Alright, we can add 2a on both sides and subtract 1 on each side. I have 2a minus 1. 1 second, I have to sneeze. Never mind, I don't. Alright, you know that feeling when you gotta sneeze but it just doesn't come out? That just happened to me. Alright, anyways, back to the subject. Alright, we have x squared equals 2a minus 1. Do you see how we got there? We subtracted 1 on both sides. We added 2a on both sides. So now, let me drag this down here. Alright, so we have this going on. And we can just square root both sides, right? If we square root both sides, we'd get x is equal to the square root of 2a minus 1. Alright, so we have x is equal to the square root of 2a minus 1. Alright, and so automatically we can rule out a is equal to 1 over 4, right? Because if a were to equal 1 over 4, then if we plug in a equals 1 over 4, we get 1 over 4 times 2, which is a 1/2. 1/2 minus 1 is negative 1/2, alright? And we can't have a negative, well, we can have a negative number inside the square root, except we'd get an imaginary number, and this circle wouldn't even be on this plane. It'd be an imaginary plane instead, alright? So you can cross out that. We can also cross out this, right? Because 1 over 4, if we plugged in a value very close to 1 over 4, we plugged in 1 over 4.0001, right? That's greater than 1 over 4. But again, it is, or if we plug in 1.3999999, that's greater than 1 over 4. But guess what? It still would not fit this constraint right here, right? So we can cross this out, and we can also cross this out right here, right? Because if we plugged in 1.3999999, it still would not fit into these constraints right here, right? With the fact that the square root has to be greater than 0. All right. I guess that if we had a is equal to 1/2, right? Well, if a were to equal to 1/2, then this square root would be 0, right? You might think that's okay, but if this square root would be equal to 0, and a was equal to, and we had a equaling to 0, then this parabola wouldn't even be on this graph right here. It would be somewhere over here, right? It'd be somewhere over there. So we need a valid point that is greater than 0, right? So that leaves us with our only answer here, which is answer E, which leaves us with a valid point crossing the y-intercept, not the number 0, alright? And it leaves us with also our circle here crossing negative a. Alright, and there you go. That is how you solve the problem. If you didn't get this problem like I didn't at first, then you should probably watch some of the video again and, just really get a clear mind of what's going on.